It's just past midnight. You're on your back in an open field, no city lights anywhere near you. And then it happens. A streak of white fire rips across the sky and it's gone before you can even point at it. We used to call this a shooting star. Nice name, wrong idea. What you just saw was a piece of rock, smaller than a grain of sand, dying 60 miles above your head, moving faster than a bullet fired from a rifle. Not falling, dying. There's a difference, and by the end of this video, you'll understand why that word matters. This August, you're going to see a lot of them. Every year, Earth drives straight through a trail of debris left behind by a comet nobody alive has ever seen from Earth. That's the Perseid Meteor shower. And in 2026, the sky is about to do something it doesn't do very often. It's going to get completely, perfectly dark. No moon, no glow washing out the faint ones, just black sky and, if the numbers hold up, close to 100 of these streaks every hour. But before we get to why this year is different, we need to talk about where all this dust actually came from. Because it's older than you think, older than almost anything you'll ever lay eyes on. This story doesn't start with Earth. It starts with a comet called 109P Swift-Tuttle, a 16-mile chunk of ice and rock that swings around the sun once every 133 years. Here's the thing about comets. Every time one gets close to the sun, it starts to cook. The heat boils ice straight off the surface, and that escaping gas drags rock and dust along with it. Do that for a few thousand years, on the same orbit, over and over, and you get a long, scattered trail of debris stretching across the comet's entire path. Earth never actually gets near the comet itself. But once a year, our planet's orbit crosses right through that trail. And when it does, thousands of fragments, most of them no bigger than a grain of sand, slam into the atmosphere at roughly 133,000 miles per hour. At that speed, they don't need to be big to put on a show. Friction with the air is enough to vaporize them almost instantly, and that burst of energy is the streak of light you see. Most of it happens around 60 miles up, above any plane you'll ever fly on, but somehow still close enough to feel personal. Now, if you trace all those streaks backward, they all seem to point to one spot in the sky, inside the constellation Perseus. It's not the meteors organizing themselves. That's just geometry. It's the direction Earth is physically flying into the debris field, the same way rain looks like it's coming from ahead of you when you're driving through a storm. Hence the name. The meteors themselves can appear anywhere overhead. The name just tells you where to trace them back to. And here's the part that actually stops people. The comet responsible for all of this won't be visible from Earth again until the year 2125. Every single streak you see this August is coming from a piece of ice that left the inner solar system before you were born. And it isn't coming back until long after you're gone. You're not watching the comet. You're watching its mail, delivered a century late. Most years, the Perseids are a solid show. This year, they're on track to be one of the best in over a decade. And weirdly, the comet has nothing to do with why. It's the moon. Every meteor shower is fighting the moon for your attention, and the moon usually wins. Even a half-lit moon can wash out the fainter meteors, cutting what you'd normally see by more than half. Think of it like trying to spot fireflies in your backyard with a streetlight on. Technically possible, mostly pointless. But in 2026, the Perseid peak lands almost exactly on a new moon, which means during the exact hours you'd want to be outside watching, the moon is basically not there. No competing light, no washout, just a fully dark sky, and suddenly even the faint, small meteors you'd normally miss are visible. That's why the numbers being thrown around this year are on the high end. Depending on who's doing the counting and where, estimates range from 50 to 75 meteors an hour, with some forecasts pushing toward 100 under perfect dark sky conditions. That's not scientists disagreeing with each other. That range is just reality. Your latitude, how dark your sky actually is, how many hours you're willing to stand out there freezing, all of it moves the number. But almost everyone agrees on the headline, this is a strong year. Then there are the fireballs. Most Perseid meteors are quick, small, fast, gone in a blink. But a portion of this debris field is made up of bigger fragments, and when one of those hits the atmosphere, it doesn't streak, it burns. Fireballs can outshine Jupiter, last several seconds instead of a fraction of one, and sometimes leave behind a glowing trail that lingers in the sky for minutes after the meteor itself is long gone. NASA's own data shows the Perseids produce more fireballs than any other annual shower. So a dark sky, a high hourly rate, and more fireballs than usual, that's already a good night. But it turns out the sky isn't just clearing up for the meteors. Something else is happening that same week. Just hours before the Perseids peak, a total solar eclipse cuts across the sky over Greenland, Iceland, and Spain, the moon fully blocking the sun for a few minutes in the middle of the day. Outside that narrow path, a partial eclipse stretches across much of Europe and even reaches parts of North America, including sections of the US and Canada. Here's the strange part. In the same 24-hour stretch, the moon blocks out the sun during the day. And then that night, its absence from the sky is exactly what makes the meteor shower so easy to see. It's the same new moon doing both jobs. One is a direct consequence of the other. The darkness erasing lunar glow for stargazers is the very same alignment passing between Earth and the Sun to cause the eclipse. For most people, this isn't really a scheduling conflict. The eclipse happens in daylight, thousands of miles from wherever you'll be standing that night with your neck craned up at Perseus. But it's worth knowing because it reframes the whole week. This isn't two unrelated coincidences landing close together. It's one lunar phase, quietly producing two completely different shows, hours apart. Which brings us to the only part of this that actually requires you to do something. Here's what you actually need if you're planning to step outside for this. The Perseids run from mid-July through late August, but the one night worth circling on a calendar is the night of August 12th into the early morning of August 13th, 2026. The exact peak is predicted for the afternoon of August 13th, UTC, which for viewers across the Americas and Europe means the best window is the night before, after midnight on August 12th, through the hours right up to dawn. That timing isn't arbitrary. As the night goes on, the side of Earth you're standing on rotates deeper into the debris stream, so meteor counts don't just stay steady, they build. The best rates of the whole night show up right before sunrise. Midnight to dawn isn't just a decent window, it's the window. Finding the radiant is easy. Step outside around 10 p.m., face northeast, and look for a bright cluster of stars shaped like a giant W. That's Cassiopeia. Perseus sits just below it. But here's the part that trips people up. Don't stare directly at Perseus. Meteors near their own radiant point actually look shorter and less impressive. The long, dramatic streaks tend to show up somewhere else in the sky entirely. So let your eyes wander. Equipment-wise, there's nothing to buy. No telescope, no binoculars. Honestly, they'll hurt you here. Narrowing your view down to a sliver of sky when what you actually want is as much of it in your eyes at once as possible. Find somewhere dark, away from streetlights with a wide-open view. Give your eyes 20 to 30 minutes to properly adjust. And once they have, resist the urge to check your phone. A few seconds of screen light and you're starting that adjustment over from scratch. Then just lie back and wait. For viewers across the US and UK, rural or quiet suburban spots with low light pollution will get you closest to that 100-hour ceiling. And unlike a lot of sky events that demand you show up at the exact right minute, the Perseids are forgiving, miss the precise peak, and the nights on either side still deliver a solid show. Which leaves one real question. Why does any of this matter beyond just being a nice night outside? It would be easy to file this under nice thing to watch on a summer night and move on. But there's a reason scientists don't treat it that casually. NASA's Meteoroid Environment Office tracks and catalogs showers like the Perseids every single year, and not just to forecast how good the show will be. That dust is data. Every fragment burning up in the atmosphere is a physical sample of material that's been drifting through the solar system for centuries, shed by a comet that formed billions of years ago, in the same cloud of gas and dust that eventually became the sun and every planet orbiting it, Earth included. So, in a very real sense, that streak of light lasting less than a second is older than almost anything on the surface of this planet. It's raw leftover material from the construction of the solar system itself, making its final appearance as a flash of heat and light, 60 miles above your head, then gone forever. Next time you're lying in a field and one of those streaks tears past, that's not a shooting star. That's the oldest thing you will ever see with your own eyes. So here's where that leaves us. This August, everything is lining up at once. A new moon wiping out any competing light. Hourly rates that could climb close to 100, more fireballs than any other shower produces all year. If you've always meant to watch a meteor shower and never actually got around to it, this is the year that makes the effort worth it. Mark the night of August 12th into the early hours of August 13th. Find somewhere dark. Give your eyes time to adjust. Look up. If you want more of this, the actual science behind the events worth stepping outside for, that's what this channel is built around. Hit subscribe so you don't miss the next one, because right now, somewhere above you, a piece of a comet older than Earth itself is already on its way in.